In this example, we want to determine the molecular hybridization or the orbital hybridization of the central atom for 3 different compounds, okay? So in order to do this, we need to have a Vsepr structure. In order to do that, we need to have a Lewis dot structure first. So the number of valence electrons for this is 4 plus 6 plus 6, which is 16. Okay, carbon is our central atom, so we'll draw it in the middle, connect it to 2 sulfurs, give them each octet. From here, we can see that while these both have octet, the carbon does not. We need to add both of our, we're going to add 2 double bonds here, one from each one, to where we end up with this molecule. Okay, from here we can draw a Vsepr structure where the carbon atom is our center. There are 2 steric centers, and so we actually know that this is going to be a linear molecule. To determine the hybridization of here, we are going to mix together an s and a p orbital, and so the carbon is sp hybridized. Now, to challenge ourselves, what about the hybridization of the sulfur atom? It turns out that these are going to be sp2 hybridized, so they will interact, 2 p orbitals will overlap in order to create this double bond, but these centers are going to be an sp2. In order to do that, one way or one technique is to count them up. You have 1, 2, 3 types of bonding interactions or bonding orbitals, and so that is 3 bonded orbitals, which is an sp2 hybridization. So let's look at GeH4. Our valence electrons are 4 plus 1 times 4, which equals 8. Ge in the center. Our Lewis dot structure looks just like this. Based on our steric number of 4, we're going to have an sp3 hybridized or a tetrahedral. They look something like this. When you hybridize 4 orbitals together, you will mix together the 1s and the 3p orbitals, which would give you an sp3 hybridized center. Okay? So last, on your handout, it's a different molecule. I decided that aluminum trichloride is a little bit better of a bet. So our valence electrons are going to be 3 plus 3 times 7, which is 24. So we have aluminum in the center, connected to 3 chlorines. Make sure we use up all of our lone pairs to create octet. We've now used 24 of our electrons, which if you notice means that aluminum is not making an octet. However, aluminum is one of the rare elements that octet is just 6 electrons. So in this case, we have a completed structure. Now, our steric number here is 3, and so we're going to end up with a trigonal planar element. And so we have aluminum trichlorides, and they look like this. So while the Lewis dot structure is also flat, we don't have any wedges and dashes in this molecule. These bond angles are 120 degrees, therefore we need to note that in our Vsepr structure. In this case, this element mixes together 1s and 2p orbitals to create also an sp2 hybridized orbital. And so those molecules are planar.